እሺ ሰልጣኞች የሌቭል 4 የሜካትሮኒክስ ኢንስቶል ሜካትሮኒክስ ዲቫይስ የሚለው የቫልቮቹ ሲምቦል ፊዚካል ኮምፖነንታቸው ምን እንደሚመስል አሁን በሚቀጥለው ቪዲዮ ላይ ያው እንደምትመለከቱት ተስፋ አድርጋለሁ። አይታችሁም ከዛ እውቀት እንደምታገኙ ተስፋ አድርጋለሁ። ያው ሶፍትዌሩን ባለፈው እንደነገርኳችሁ ያው ለሁላችሁም ሌቭል 4 ለምትማሩ ሰልጣኞች በሙሉ ነው ማስተላልፈው ማለት ነው። ሌቭል 4 ኢንዱስትሪያል ላይ ወይም ደግሞ ሜካትሮኒክስ ሲስተም ለምትማሩ ስፔሻሊ የዩኒቲ ኦፍ ኮምፒታንሲው ኢንስቶል ሜካትሮኒክስ ዲቫይስ የሚለው ላይ የምትማሩ ሰልጣኞች ሞስትሊ የቫልቮቹን ባለፈው ያው እንደነገርኳችሁ የወርኪንግ ላይ የፓወር ኮኔክሽን የኮንትሮል ኮኔክሽን ወይም ኮንትሮል ላይን እና ኤግዞስት ላይን የሚባሉ ሲስተሞች የተወሰነ ቲዮሪ አይታችኋል። የሱ ማረጋገጫ ለምሳሌ በአካል ብታገኙ ምን ይመስላል ይሄ ቫልቭ ስፔሻሊ የዲሲቪ ታይፖች ምን ይመስላሉ የሚለውን በተወሰነ መልኩ ልታዩ ትችላላችሁ። ሶፍትዌሩን ግን ፍሉድስ የሚባል ነው። ካገኛችሁት ኢንስቶል አድርጋችሁ ብትጠቀሙ ደስ ይለኛል። በተጨማሪ ያው ቪዲዮውን ወዳችሁት ትምህርትም አግኝታችሁበት እንደምትረኩና እንደምትደሰቱ እንደምትጠቀሙ ተስፋ አድርጋለሁ። ይመቻችሁ። ወዳችኋለሁ። ያው እንግዲህ ሰብስክራይብ በማድረግ ቤተሰቡን ሰብስክራይብ በማድረግ ደግሞ ደግፉ። አንዳንድ ትምህርታዊና የሲኦሲ መረጃዎችንም የሌቭል 4 ያልተፈተናችሁ ከሌቭል 1 እስከ 5 ያሉትን ጥያቄና መልሶችንም እዚሁ ቪዲዮ ላይ ፖስት አደርጋለሁ። ስለዚህ ቪዲዮ ሲጫን መጫኑን የሚነግራችሁ ኖቲፊኬሽን ለማግኘት የደውል ምልክቷን ኦን ላይ በማድረግ ክሊክ ብላችሁ ማግኘት ትችላላችሁ። ተከታታይ ትምህርታዊ የሆኑት ቪዲዮዎችን ሳይንስ ኤጁኬሽን የሆኑትን ጭናለሁ። እሱን በመከተል ማወቅና መጠቀም ትችላላችሁ። አመሰግናለሁ።
Hello and welcome to Tesca Technologies Private Limited. In today's video, we are going to discuss about Tesca's very new electro-pneumatic workbench. Order code for this workbench is 52104B. So this kit basically gives brief introduction about the electro-pneumatic components which are nowadays using in industrial environment. We also provide PLC control with this component to give better understanding in the industrial processing. So this electro-pneumatic workbench comes with some basic electro-pneumatic components in which this is a double acting cylinder. Also there are some limit switches to operate the double acting cylinders process. Another double acting cylinder with the roller lever actuators. This is a single acting cylinder which also providing proximity sensor. This is a O valve or shutter valve. These are the flow control valves for different cylinders. These are the 5x2 single solenoid valves, also a 5x2 single solenoid valve, 3x2 single solenoid valve, and a hand lever operator 3x2 solenoid valve, 5x2 solenoid valve. And this is a palm actuator or push flush head actuator. This is a manifold, junction manifold. The incoming air line will be provided here. This is a analog pressure gauge, and this is the FRL unit, filter, regulator and lubricator unit. We also provide Siemens PLC logo series of 12 input and 8 digital outputs with a junction box. The junction box consists of 3 NO switches and NC switches. Also connection, and we are also provide 24 volt power supply to operate the PLC connections and control the different coils and sensors. Also provide some patch cords to connect the connections, PU tubes for pneumatic connections, and some sensor and connecting cables to connect solenoid coils and proximity sensors as well. We also provide a LAN cable for PLC interface and the communication software to communicate and program the PLC. So now I will show you how to use the PLC, and we will program PLC to perform the different exercises with these components which are provided with this electro-pneumatic workbench. So before doing the exercises, we first make sure the incoming line will be connected to the FRL unit. This is the incoming line from the compressor. So the compressor incoming line will be connected here, and this arrow will show how the air should be passed on through this FRL unit. Now the output of this FRL unit will be connected to the manifold. So this is the basic connection which remains same for the all connections. Now we will use a 4 mm PU tube, and to see the pressure we will connect this PU tube to this pressure gauge. Now I will on the so now I will open the valve of this compressor, and the pressure is shown at the FRL unit. Make sure the FRL unit should always be in vertical direction, so the oil lubrication are not in case of leakage. So this is the right now pressure is not showing it is vacuum pressure gauge. When we on the wall of this manifold like this, the pressure shown at the pressure gauge is right now about 4 bars. So this is manifold unit. Whenever any point is connected through PU tube, the air is starting passing through that PU tube. So now first we will perform the exercise of double acting cylinder. So we will use a 5x2 solenoid valve of single coil, and we will program the PLC to do the single cycle operation of a double acting cylinder. For this, first we will connect the manifold, any of the output from the manifold. Make sure before using manifold the wall of manifold will be closed at this time before making connection, otherwise the air will be leaked. So this output from the manifold will be connected to input of the 5x2 solenoid valve. Now one of the output from this solenoid valve will go to the flow control valve, and other input of this solenoid valve will also go to other flow control valve. Now we will connect the flow control valve to the one end of the double acting cylinder, and also the other flow control valve will be connected to the other end of single acting cylinder. So double acting cylinder. So these are the basic pneumatic connections which I have done. Now we will do the electrical connections. So now after making the pneumatic connections, we will control this cylinder using PLC. For this we will have to power on the PLC. So we will connect the 24 volt supply to this junction box, and positive of this PLC junction to positive of the PLC and negative to the negative. So when we also need to short circuit the positive negative junction box to give the proper connection of this PLC junction. For this we need to short circuit this positive terminal and this negative terminal as well. So now we will power on the 24 volt power supply and our PLC is now on. So we move on to the programming section. For this we will use the LAN cable. The one end of this LAN cable is already connected to PC and the other end will be connected to the PLC to this Ethernet port. So now we will move on to the programming section. For this programming of this PLC we will use Logosoft Comfort version 8.0.1. So this is the software which will be used to programming this PLC. So making the program will be make the lengthy this video. So we have already programmed the PLC before. So this is the program of double acting cylinder using 5x2 solenoid single solenoid valve. So this program will be downloaded to our PLC with this download button. So this is our IP of our PLC. We will test the connection. The connection is perfect. Now press OK and the program will be downloaded to the PLC. So for measurement or to simulation we will start up the online test. We will use it after we make the electrical connections. So now we will make the electrical connection as per the program. For this we will connect NO button first to the 24 volt power and the other end of this NO will be provided to input 1 as defined in the program. So now we required a sensor cable. So we will connect this limit switch cable to the cable of this limit switch like this. And limit switch works as an NONC program. So for this we will provide 24 volt to one end of this limit switch and the other end will be provided to input 2, which is defined as the A0 input of the limit switch. So now we will use the other sensor, which is the A1 limit switch. Also connect this with this 2-end cable and the input will be connected to 24 volt supply and output will be going to input 3 in the junction box as we defined it. So our connection for output we will require the coil. So the negative end of this coil will be goes to negative and the positive will be at Q1. So this is our output which is defined in the PLC. So as the output goes high, this coil will be working starting and which will work to operate the cylinder. So our electrical connection has been done. Now we will on the manifold valve. We can see the pressure is at now 4 bars. So we will push this button and will give the input to the PLC, and the output will be come, and the single cycle of this double acting cylinder will be occurred. So as I give the input, again I give the input. So this is how the single cycle going to happen. As I give input, the cylinder goes to forward, and then as it reaches to the limit switch, again the output goes off and cylinder come back. So this same cycle can be simulated at the PLC program. You can see as I give the input I1, the cycle goes to the I2 sensor through magnetic OI. So in the simulation you can see the double acting cylinder single cycle is working. So here we have performed the double acting cylinder using PLC and using single solenoid valve 5/2. So now we will move on to the second exercise, which is to manual control the double acting cylinder by a hand lever valve. For this we first close the junction box and remove the input connection of this 5/2 solenoid valve and we will connect this to the 5/2 hand lever valve. So this is the hand lever valve. Same connection will be done as we done to the 5/2 valve. Just the difference is that firstly it will be controlling by the PLC, now it will control manually. So now we will on the manifold valve. You can see the cylinder goes forward. So as I move this hand lever valve to the right direction, the cylinder goes to back again inside and again. So this is the manual cycle, manually operated by hand lever valve. I will also explain the flow control valves. As we loosen the bolts of these flow control valves, you can see the speed of the piston stroke of the cylinder will be increased as the flow is increased through this flow control valve. So the speed is increased right now. I will loosen some more. As I tighten the flow control valve, the flow of control air is happen and the cylinder goes forward in slow as I tighten the forward section of this flow control valve. So right now you are seeing that the cylinder is going far from this limit switch. So the limit switch can be easily adjusted like this. These are easily mounted sections on this aluminum rail and on this inclined plate. So we can see the after complete stroke we can adjust this limit switch like this properly. Now the stroke is complete. So that's how we control the double acting cylinder using hand lever valve. So now we move on to the single acting cylinder, single cycle with 5x2 solenoid valve. So for this, the electrical connections and the programming section will remain same, just we have to change the pneumatic section. So for this, we will first remove this PU tube from the double acting cylinder and connect it to the single acting cylinder. Now we will remove this proximity for a second and open this limit switches, and these will be connected like this here, and we have to just remove the other line of this pneumatic section, and we required a stopper to stop the other end of this 5x2 valve. So we as we all only required one side of this 5x2 valve, so now we on the manifold valve, and again we will see the single acting cylinder cycle. So we can see the limit switch has not reached to the single acting cylinder. So here we can see the cycle is not operated because the piston of this and stroke of this single acting cylinder is limited, and it cannot be able to operate this limit switch. So as I operate this manually, the cycle completes. So we will use the proximity sensor for this purpose. So this proximity sensor we will use. So we will see the, so to properly set the proximity, we first expand the cylinder, and here will be our proximity reaches the piston. Now we will connect the cable of proximity sensor with this connector like this. And we will remove the A1 proximity connections. Instead we will use the proximity sensor on the place of limit switch. For this, we will properly connect the proximity. For this, this is the 24 volt positive supply given to the brown, and negative supply will be given to the blue, and black will be the output. So output will be connected to the I3, same as the limit switch, and positive will be connected to positive 24 volt, and negative will be connected to this. So as we connect the negative, the sensor operates and the cycle goes complete. Again we will perform the cycle with a limit switch and a proximity switch. So this is the single acting cylinder using proximity, limit switch and 5x2 solenoid valve. So now we will move on to the multi-cycle operation of double acting cylinder. For this we will use this double acting cylinder, and we will do the pneumatic connection first. For this, connect an output from the manifold to a 5x2 valve. We will use a 5x2 solenoid valve for this, and now we will connect the one end of this 5x2 solenoid valve to the one of a flow control valve. Also similarly we again connect a flow control valve to one end of a double acting cylinder. We will again repeat the same cycle for other side of double acting cylinder, and we will connect this flow control valve to the output. So these are pneumatic connection which are done. Now we will move on to the electrical connections. For this we first program the PLC. So I have already prepared the program of multi-cycle operation of DSE. So we will open this multi-cycle operation program. So this is the program. We will download this program to the PLC. So this using this section which is PC2 logo. So this is our PLC. We will select this, test this, and now we will download this program. So our program has been downloaded. We will start simulation by online test. So this program is now in online test. We will do the electrical connection as per the program as we defined the all inputs. So we move on to the electrical connections. For this we will use first limit switch cables and connect this limit switch cables to the connectors of limit switch like this. So this is our A0 limit switch and this is our A1 limit switch. Properly align the connector and properly tighten the safety screws. Also we will connect the solenoid coil of 5x2 solenoid valve. For this we will connect the cable for the 5x2 solenoid valve. Now we will use patch cords to connect the inputs. For this we will first connect the start push button. For this we will give 24 volt to NO section of this NO button, and other terminal of this NO button will be goes to input 1, as we defined here that the input 1 is start push button. Now we also use stop PB in this. So we will give this red push button as an stop push button. So we will connect 24 volt to the one end of this stop push button, and we read a longer cable for this, and we will connect the other end of this to I2. So I2 is our stop push button. Now we will connect the limit switches. So our first limit switch is A0, which will be given to the input 3. So one end of this limit switch will be connected to 24 volt supply and the other end will be connected to I3 input. Similarly, the A1 limit switch will be connected like this, 24 volt to 24 volt supply one end, and other end will be connected to I4. And for output we will connect one end to the negative and one end which is the output Q1 of this solenoid valve. So we have done our electrical connections. So after doing the electrical connections, we will perform the multi-cycle operation of this double acting cylinder. For this, first we will open the air wall of this manifold. We can see pressure is now showing at the pressure gauge. All electrical connection are verified. So we will give input from this push button. So this is the input. Sorry, stop push button was pressed already, that's why input is not going. Now I have opened the stop push button. So as I give the input, you can see the multi-cycle operation is going on till I press the stop push button. So as I press the stop push button, the multi-cycle operation has stopped. Again I open the stop push button and we will give input and start the multi-cycle operation. So this is the multi-cycle operation which we have programmed in the PLC. You can also understand this by online tests of simulations. So this is our multi-cycle operation of double acting cylinder. So now we will do the next experiment, which is counting of forward movement of a double acting cylinder. For this we will use the same pneumatic and electrical connection. Pneumatic connection will be the properly same as in the multi-cycle operation. Just we have to add a proximity here to counting the forward movement. Just remember, when we use working with proximity, always use the metal end of the front end of the cylinder, because proximity only sense the metal. So now we will place the proximity here and do the connections of proximity with this 3-point cable and connect this connector like this. So in multi-cycle we will program also. So in proximity there are 3 wires, which is brown will be goes to positive 24 volt, blue will be going to negative, and black will be output, which is going to input 5. We have defined the input program in this PLC program. So I will download this program of forward counting of forward movement. So this is our program of counting of forward movement. In this program we have defined the 5 counts to forward movement of this multi-cycle operation of the piston of the cylinder, double acting cylinder. So we can change this as we required. So these are the on count, which is 0. At this moment, from 0 counts the program run and starts the counting of cylinder, and after 5 counts this will be off. So we have defined the 5 counts here. Now I will download this program to the PLC. So we have downloaded this program, and now we will start simulation, and we move on to the workbench section. So we have already done the connection. Now we will test this program. For this we will start and properly align the proximity just beneath the limit switch. So the front end of this double acting cylinder should reach the proximities face. Now we will start the cycle. Before this we will on the manifold wall for air, and now we will start counting 1, 2, 3, 4 and 5. So these are the forward counting. Now as I change the counts from this counter at 10, so after 10 counts the multi-cycle will be stops automatically. After changing the counts, we have to download the program again and we will start simulation. So we again start this cycle, and after 10 cycles the cylinder automatically stops. We do not stop this time as we are stopping it in the multi-cycle operation. So we start this 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So these are the forward counting. We can also program different combinations from this multi-cycle and single cycle cylinders. We will going to perform the single acting cylinder operating by a hand operated or palm actuator. For this we will connect this output of this manifold to the input side, which is the 1 number point at this palm actuator here, and output of this palm actuator will be connected to a flow control valve for safety purpose, and output from the flow control valve will be connected to the single acting cylinder. So this is our single acting cylinder. Now as I press this push button or this palm actuator, the single acting for this, first we will on the air valve of this manifold, and now we will press the palm actuator. The cylinder, we will notice the forward movement of the piston of cylinder. As I release this, the cylinder going backwards. So this is the working of a palm actuator manually controlling the single acting cylinder. So now we will perform the next experiment, which is the same operating of the single acting cylinder now, but this time we will use the 3x2 solenoid coil. So this will be the PLC operated. For this we will remove this input of the palm actuator and will be connect to the 3x2 valve. So this is the 1 number terminal of this 3x2 valve, and the output is the other end of this valve. So these are the pneumatic connection, rest of the connection remains same. Now we have introduced the 3x2 valve. Now we will connect the coil to operating the power supply of this valve. For this we will connect this coil cable and we will program the single coil operating program which we have downloaded to this PLC. So this is the single acting coil program. For this we will just use a start and stop PV from the PLC to on and off this solenoid coil. So this program has been downloaded and it is now in simulation. So we will perform the electrical connections. For this we will introduce a push button. Now we will connect 24 volt to the 13 number terminal for the start push button, and the other end of this terminal will be going to input 1, which is the start push button defined in the PLC program. We also use one stop PB. For this we will connect the input 2 and we will also provide 24 volt to this 13 number terminal of this stop PB. Now we will connect the output. For this we will connect this coil positive to the 24 volt and output will be going to Q1. So that's our electrical connection which will be used to operate the solenoid coil. Now we will on the air from this manifold and we will press the start button. So for output we will use the coil and we will connect this coil to negative, and output will be coming from the Q1 like this. And now we will operate this cylinder. For this we will open the air valve of manifold and press the start PV. So that's how our cylinder is started. Coil is now at running position, where as we want to stop this, we will press the stop PV. So that's how we will use the 3x2 solenoid valve to operating a single acting cylinder. Now we will explain the roller level actuator. So this is a roller lever actuator. For this comes in use when we want to operate any other movement by one movement. So this movement of forward cylinder will operate this roller lever, and this roller lever will operate the single acting cylinder. From this we will first connect this double acting cylinder to operating with this 5x2 solenoid valve. The output of this valve will be connected to double acting cylinder. Like this. And now we will do the pneumatic connections for roller lever. So this is the output of this roller lever, and this will be going to single acting cylinder. And for input we will use a manifold, and we will give this input to the roller lever. Now our pneumatic connection has been done, and we will use the same connection for on and off the solenoid. For this we will just stop the solenoid for the operation of this double acting cylinder, and operation of single acting cylinder will be happen by the roller lever actuator. So as I on the air valve, you can see that as I on the air, without on the solenoid, the cylinder operates. Just this is due to the reverse connections of the cylinder. For this we will just off this, and we will reverse the connection for solenoid. So as I again on the air, right, this time this is the perfect connections. So this is the power on of solenoid and the operation, and as I stop, the roller lever also stops, and the cylinder also goes to reverse, the single acting cylinder. As I again operate this start push button, and as the forward movement of this double acting cylinder goes, this will operate the roller lever actuator, and the roller lever actuator will operate the single acting cylinder. So after removing the stop button, we will start this. So you can see the cycle of this roller lever actuator. We will stop, and the cylinder comes back. So that's how we use the roller lever actuator. This will be used in different industrial purposes. When we used any one movement of any cylinder will be used to operate the other movement of any cylinder. Now we will use this OR valve to operate a double acting cylinder. So this is a OR valve or shutter valve. This will be basically operates from one input. When one input is coming, the output will occurs, but when the input one of the input is giving the air line to this valve, the other input will be blocked. When the other input will be giving the air, then the first input will be blocked. So that's how this OR valve works. Now we will do the connections. For this we will use one palm actuator and a 5x2 solenoid valve, which is hand lever operated, and we will do the operation of this double acting cylinder using this solenoid coil valve 5x2. For this we will first do the connection of double acting cylinder of 5x2 valve. For this we will use the OR valve's output to giving input. We will use a smaller tube for this. So the output of this 5x2 valve, which basically the operation which will be used to operate this double acting cylinder, will be given from this OR valve. So for this incoming of this OR valve, we will give one incoming line from the hand operated lever 5x2. So this is the first incoming line of this, and other incoming line of this OR valve will be coming from the palm actuator. So this is the basic line connection. So first incoming will be coming to the from the hand operated, and this is the manually palm operated. So these are the two incoming lines, and the output will be one at a time. Let's describe the OR valve. Now we will do the connections of double acting cylinder. In case if we find the reverse operation, we will reverse the terminals as we required. Now I need a PU tube to giving input to both of the hand operated manually operated valves. So this is going to the palm actuator, and this input will be going to the 5x2 lever valve. One end of this 5x2 we have stopped with this stopper. So we just need a one output from this 5x2 lever. Now we will program the PLC as per the on and off circuit to just we want to on and off this solenoid coil to operate and perform the double acting cylinder operation. So our pneumatic and electrical connection has been verified. Now we will first on this 5x2 valve. So the 5x2 valve's output will be going to the OR valve. Now as we press the on input, the cylinder operates. As I press stop, the cylinder again goes backward. So this is now operating from the 5x2 valve. At this time, as I input and press the palm actuator valve to giving the input, this will not going to the OR valve because the first input already coming from the 5x2 valve. So this will not affect the 5x2. As I remove the air line from this 5x2, so this is the I off manually this 5x2 valve. Now you can see it's still not working because I do not push the push button of this palm actuator. So as I operate this palm actuator, and I will press till we operate this by 5x2 valve solenoid coil. So this is now operating from the output of the palm actuator. So that's how OR valve works. When I giving the input from OR valve like this, this not affect the output of 5x2. The input of this OR valve will be not affected from this 5x2 valve. You can see and hear the air noise which is going and inside but not affecting the output. So as I remove the 5x2 coil, the air line to the double acting cylinder will also removed. So as I give input from the 5x2, now we will stop and the coil stops and cylinder working. So now last we will perform the sequencing operation of two double acting cylinder. So first we will perform the A plus, B plus, A minus and B minus cycle. So I will explain the what is A plus and B plus. So this is a cylinder. This is when this cylinder going forward. So this is the A plus cycle of this cylinder and this is the A minus cycle of this cylinder. So forward movement will be considered as A plus and reverse movement will be considered as A minus. So similarly, when we use two cylinder, so we will define this as A and this is defined as B. So as it goes forward, which it will be from A plus, and as it goes forward, this will be B plus. So the both cylinder will going to first A plus and B plus, and then after 5 seconds this both the cylinder will come back, which describes the reverse movement, which is the A minus and B minus. So this is the sequencing operation. So sequencing operation program has been already done. I have made up already, so we do not have so much time in this video. So this program will be provided to you also. So this is the sequencing program of A plus, B plus, A minus, B minus. Now we will download this program to the PLC. So this program is downloaded to the PLC, and we will remain this PLC on the online test mode. Now we will first do the pneumatic connections. For this we will use two solenoid valves. So first solenoid valve will be this 5x2 solenoid valve. The input will be connected from manifold, and the other solenoid valve will be given input from this manifold. Now just remember one thing, while connecting the solenoid valves, always connect the same terminals to the same output of the cylinder. So as I connect the left terminal of this solenoid valve to the back end of this cylinder, so similarly at the other cylinder you should also connect the left terminal to the back end of the second cylinder. Now the front end or the right end of this solenoid valve will be connected to the forward section of this cylinder. So similarly the front end of this cylinder will be connected to the forward end. So the A plus and A minus cycle will be same for the both the cylinder. Now we will do the electrical connections. For this we first include a start PB. For this we will give 24 volt to this 30 number terminal, and 14 number terminal will be going to input 1. So this is our input. Now we will connect the output. For this we will just need solenoid coils. So this is the A solenoid coil or S1 solenoid coil. The negative will be connected to negative, and output will be coming from Q1 for the first solenoid valve, and for other solenoid coil we will give negative to the common terminal, and positive will be coming from Q2. So we will connect this solenoid to Q2. So this one will be the output 1 and this will be the output 2. Now we will on the valves. You can see the cylinder is both the cylinder right now at the minus positions. So now as we give the input, both the cylinder, you can observe the forward movement in both cylinders, and which is the A plus and B plus movement again. And after 5 seconds we have defined a timer for 5 seconds. The B plus and B minus and A minus movement will be happen. So this is the sequencing of two cylinders, A plus, B plus and A minus, B minus. So that's how you can use the sequencing. You can also use different combinations for A plus, B minus, B plus, A minus, which are also given in the manual. Just need to connect the lines or the solenoid coils to the different combinations. You can also perform different combinations from these components, using all the components from different combinations. For more details about this circuit, that's how we done work at the electro-pneumatic workbench from Tesca. For any details about this kit and to purchase and to about any queries, you can contact to Tesca.
ያው ቪዲዮ ተመችቷችኋል? ዝናብ ስላለ ነው ይሄንን የለበስኩት። ቪዲዮ ተመችታችኋል? ሰብስክራይብ በማድረግ ላይክ በማድረግ ያው ላልመጣ ተማሪ ደግሞ ሼር አድርጋችሁ ዳውንሎድ አድርጋችሁ ሼር አድርጋችሁ ይሄን ቪዲዮ እንድታደርሱ ጠይቃችኋለሁ። ሰብስክራይብ እንዳረሱ ቅድም እንዳልኩት በተከታታይ ቪዲዮዎችን ልካለሁ። ስፔሻሊ የኢንዱስትሪያል ኤሌክትሪካል ኮንትሮል ተማሪዎች ከዛ በተለይም ደግሞ የሜካትሮኒክስ ሌቭል 4 ሰልጣኞችን ይመለከታል። ቤተሰብ ሁኑ። ቪዲዮውን ያው የተለያዩ ትምህርታዊ ነክ ሳይንሳዊ እና ትምህርታዊ ነክ የሆኑት ክህሎትን የሚያሳድግ እውቀትን የሚጨምር ቪዲዮዎችን እዚህ ላይ ለቃለሁ። ባለኝ እውቀት ልክና በማቀው ለኔ ገባኝን ለእናንተ የሚሆነው እናንተ ደግሞ ይህንን ቪዲዮ ሰብስክራይብ በማድረግ ላይክ በማድረግ በተለይ ሰብስክራይብ በማድረግ ቤተሰቡን ወዳችኋለሁ። ይመቻችሁ።